do that? Well, check this out. See this little piece of candy right here? I'm going to take it, grab it, shake it a few times, and poof, it's gone. Of course, it's in this hand, but a lot of times we want to know the details behind the scenes of how did he do that, or how did that get pulled off? Well, in our networks today, there's not a lot of magic that goes on. We have a lot of protocols that are all working and cooperating together. Above me at the very top of the screen, we have the physical topology. And in the middle, we have the logical topology. I'd like to walk you through step by step of how we can leverage the technologies that exist, VLANs, trunking, access ports, routing protocols, and layer 3 addresses to build a network, which in reality is the top network, the physical infrastructure, but it appears and feels like the middle network, which is the logical network. Let's jump right in. You know, it's really interesting how sometimes we as users of networks maybe don't appreciate all the details of what's really going on behind the scenes. In this discussion, we're going to take a look at a logical topology versus a physical topology, and I'm going to walk you through configuring all of this to make this network function. If you are brand new to networking, I would recommend you pause this for a moment, subscribe to my channel, and on my channel I've got a video on VLANs, on what a broadcast domain is, what a trunk is, and I'd recommend you go through those basics first. So this presentation is assuming you understand the concept of a layer 2 broadcast domain, or VLAN, and also the concept of trunking. Okay, so here we go. We've got this beautiful PC right here, and it's connected to the 10.0.0 network, and R4 is the router for that network. So when the PC wants to talk to the server, the process goes like this. The PC says, oh, I need to talk to 30.0.0.10, and it looks at its own IP address and says, gee, is the 30.0.0.10 IP address, is that local on the network I'm connected to, or is it remote? And you and I can both see that the 10.0.0 doesn't match 30.0.0, so it's remote. So the PC is going to use its default gateway. The default gateway can be configured on this PC as a DHCP client, or we could statically configure it. It doesn't really matter how the PC learned that R4 at 10.0.0.2 is its default gateway. It's just important that the PC knows where to go for help. The PC is going to use R4 as the next hop. It's going to go ahead and do an ARP resolution to resolve the layer 2 address of R4 to figure out what the layer 2 address is of the frame. If layer 2 addressing and MAC addresses are brand new, I would also recommend take a look at the OSI reference model videos that I have that go through the logical functionality that happens in a network. So the PC is going to forward a frame to R4. R4 is going to do a route lookup, forward it to R6 if he has a route, and R6 is going to forward it on to the 30.0.0.10. Now, that's what we see in the logical topology, but behind the scenes, oh my goodness, there's so much more that's going on. Let's take a look at the physical implementation of this network. What we've done here for convenience is I've identified the ports that are going to be assigned to the specific layer 2 broadcast domains, or VLANs. And really, who controls the breadth and the length and the width of a VLAN? And the answer is your switches control all of that. I mean, this little PC is connected into the switch, so is this router, so is this router, but it's really the switch controlling the individual ports and assigning those ports to the correct VLANs that make it all work. So this red circle right here represents VLAN 2. And in this case, we have FA01/2 being assigned to VLAN 2 and also 1/5. And that's just like this here. We have the PC and the router both as a part of the same broadcast domain. And that's what we're doing here with this VLAN represented by red and the red ports. We also have a VLAN that's going to be connecting and allowing R6 and R4 to talk to each other. And that VLAN I've identified with the switch ports in blue. So logically, R4 is FA00 and R6 is FA00 are both exactly in the same VLAN, VLAN 23 in this case. So this switch here says that port's a member of 23 and that port's a member of 23, and the trunk allows those two to talk over that logical layer 2 broadcast domain. And then we have VLAN 3, which is represented in green. So in VLAN 3, we've got ports 1/5 and FA1/3, both assigned to VLAN 3. So what we've done is we've implemented with the physical infrastructure what logically is being shown right here. So if we squinted and looked at it, we have one network segment with 2 devices in this broadcast domain, another portion of our network with 2 devices in this broadcast domain, and another network segment with 2 devices in this broadcast domain, just like this. Now, it's really easy to set up as well. Let's take a look at switch 2. On switch 2, we'll simply go there and tell the interfaces, say, dear Mr. Switch 2, FA1/2 belong to VLAN 2, and FA1/5 belongs to VLAN 2. It's really that simple. We'll also tell it that FA1/4 belongs to VLAN 23. And that's how we divide and divvy up the actual layer 2 control of who belongs and what ports belong inside of each and individual broadcast domain. So here on switch 2, let's go ahead and set up the access ports and assign each of those ports to the correct VLAN. Now, by default, most switch ports are willing to negotiate if the port is going to be an access port, like right here, or a trunk port. So we're not going to leave anything to chance. We're going to go ahead and we're going to hard code each one of them. So we'll go to interface FA1/2, and we're going to say, dear Mr. Interface, you are going to be an access port. And you're assigned, furthermore, you're going to be assigned to VLAN 2. It's done. Next, we'll go to FA1/5. And interface, let's do 4 first. Let's go to interface FA01/4, and that's going to be a member of VLAN 23. So we tell it that it's an access port, and then we tell it that it's going to be assigned to VLAN 23. And then last but not least, let's do this port as well. Interface FA01/5, we're going to tell it once again, you are an access port, meaning not a trunk, and you are statically assigned to VLAN 2. So that's how we control which ports, who's coming in, belong to which VLANs. And then we can verify this with the show interface FA1/2, and it will tell us, we have the keyword switch port, it'll tell us specifically all the details about that port. So here's the details about that port. It's administratively configured as an access port, and it's currently operating as an access port. It also happens to be assigned to VLAN 2. So that's it. How many commands did we cover so far? Really, just 2. These 2 commands right here. Switch port mode access, switch port access VLAN X. And we'd also want to make sure that VLAN X exists on our switch. And if it didn't, when I created that, when I assigned the port to that VLAN, it would automatically create it for us. That's it. So we've configured these 3 ports on switch 2, these 2 to belong to VLAN 2, and this port here to belong to VLAN 3. Now, what do we need to do next? Well, let's configure our trunk links between switch 2 and switch 1 and switch 3. So we'll do that by going to interface FA1/11 and interface FA1/12. Now, we could do those interfaces, FA1/11 and 12, individually, or we could use a little shortcut called the interface range command. I mean, if you've got to do the exact same configuration on 2 interfaces, why not group your shots? That's my point of view anyway. So we'll go to interface configuration mode here on FA1/11 and 1/12. We'll say interface range, and then we'll tell them both that they are going to use .1Q encapsulation for any kind of trunking they do, and then we're not going to let them decide to negotiate trunking. We're going to say, dear Mr. Switch Ports, you are trunk ports. So the 2 commands here are switch port trunk encapsulation .1Q and switch port mode trunk. And you know what? It really doesn't matter if we do it interface by interface or in a range. It's just those 2 commands. So we have to do the other side to make this all work, but let's just revisit here what we've done so far. We told these 3 ports that they are access ports, and we assigned them to the correct VLAN. We told these 2 ports that they are going to be trunk ports. And as soon as we configure switch 1, we'll have a better chance of that actually occurring. So let's go configure switch 1 and make that a reality. One of the challenges is to make sure you're on the right device as you configure it. So we'll go to this middle switch here, and it has some messages because this side is configured as trunk and this side is not. So let's go ahead and configure switch 1 to configure FA11 and 12 to be trunk ports. In fact, while we're at it, check this out. 11, 12, 13, and 14 are all going to need to be trunk ports, so we can configure all of them at one time. So on this middle switch, really simple, we'll simply configure these trunk ports. And it's FA1/11, 12, and we'll also need 13 and 14. We can do them all at one time with the range command. So we go into interface range for 11 through 14. We specify the trunk encapsulation we want to use if this port is a trunk, and then we specify that we want it to be a trunk. So there's no negotiation involved whatsoever. So now that we've done the encapsulation in the mode, we also have to go ahead and do switch 3 to make sure that switch 3 is also configured as trunk ports right here at 13 and 14. Now, before we go over there, I just want to verify that from switch 1's perspective, that 11 and 12 are currently working, and we can just do a quick sample with a show interface, FA1/11 space switch port, and that will show us the switch specific characteristics of that interface. So it shows us that we have the administrative mode is trunking. That means we've configured it to be a trunk, and congratulations, it is a trunk. So that's currently what's happening with the trunking status. So now let's jump over to switch 3, and we'll configure these 2 trunk ports on switch 3 as well as these 3 access ports. 1/4 will be in VLAN 23, and the green VLAN is representing the VLAN 3 itself. So VLAN 3 is green. We'll put these 2 ports there so that the server and the router interface will both be in the same broadcast domain. So let's start with our access ports right here on FA 1/3, 1/5, and 1/4. So we'll go into configuration mode for each of those. Well, we're going to do the same things we did over on switch 2, and that's really simple. Switch port mode access says you, Mr. Port, are an access port. And then furthermore, switch port access VLAN 3 says this port is assigned to VLAN 3, which will be the case for 3 and 5. And then for 4, we'll assign that one to VLAN 23. So it's like a replica of the same commands we used over here. And now we're simply assigning these access ports over here on switch 3. And the way we'd verify this too when we're done is we do a show interface FA something switch port, and it will show us the details of that switch port. So once we have 1/3 is done, 1/5 is being worked on, and then we'll go ahead and do 1/4. And then to verify it, we can just do a show interface for FA 1/3, this guy right here, space the keyword switch port, and it will tell us how it's administratively configured as well as how it's operating at the moment, because there are opportunities when we could negotiate trunking, and so whether or not trunking actually took would be the operational state of the interface. So hopefully FA 1/3 is simply just an access port and administratively configured as an access port. It's operational as an access port, which is perfect, and the access mode is for VLAN 3. Why? Because that's what we assigned it. Now the next task is to get these 2 interfaces, 13 and 14, set up as trunks so we can set up a trunking relationship, if you will, between switch 3 and switch 1. So because 13 and 14 are both in the same switch and they're going to have exactly the same commands for trunking, we'll simply do those in an interface range as well. So configuration mode, interface range for 13 and 14, these guys are right here, and we'll tell that they're both going to use .1Q encapsulation, and we're also going to specify trunk. Now, you may be on a switch that doesn't even support ISL, and as a result, you don't have to specify the encapsulation, but to err on the side of caution, I throw it in just to make sure that we're going to have matching encapsulation on both sides. And then we can verify it really simple with a show interface trunk, and it will show us all the trunks as well as what VLANs are being allowed across it. So here's the command, which is show interface trunk, and it shows us that these 2 interfaces are indeed trunking, the native VLAN is 1, and that we aren't negotiating trunking. It's hard-coded, and it's currently in place, and there's the encapsulation we're using. And we're allowing VLANs 1 through 4094 through those trunk ports, and currently the only active VLANs that we have are VLANs 1, 2, 3, and 23. So the red represents VLAN 2, the green represents VLAN 3, and the blue represents VLAN 23. And all those VLANs are being allowed through the trunks. Now that doesn't mean a switch has to send every single frame through a trunk. Check this out. Let's say this PC right here is talking to its default gateway. Just for that conversation, the frame as it enters the switch would know the MAC address of R4, the router, and it would forward it right there. It wouldn't bother sending a frame from this out any other port because it's a unicast frame and that's where it belongs. Now, if this PC sent a broadcast out, in that case, the switch would receive it on this port, it would send the broadcast out port 1/5 and any other ports that were a member of that same VLAN. Now, because trunks belong to all VLANs, or all VLANs are allowed across the trunk, that broadcast from this PC would be forwarded on the trunk. It'd be tagged as this belongs to VLAN 2. Switch 1 would receive it. He would forward it with a tag that says this belongs to VLAN 2. And switch 3 would receive it, at which point switch 3 says, I don't have any other ports involved in VLAN 2. I'm going to filter that and not send it to anybody. But indeed, the broadcast would go all the way down the trunk, and there's a separate process called pruning that we'll get into in another video. So now we've got our access ports configured, we've got our trunk ports configured, and now all we need to do is configure our routers, R4 and R6, so they can route for the 10 network and the 23 network, and it looks just like this. So R4 and R6 need to exchange routes or use static routes, and then as long as this server uses R6 as a default gateway, and this PC uses R4 as a default gateway, which those are already configured, by the way, there should be full connectivity available between network 10 and the network 30. Now, before we jump onto R4 and configure it, it would be really good to verify that our physical connectivity is actually going where we think it's going. And how do we verify that? Well, the answer is we can use CDP, the Cisco Discovery Protocol. On R4, we can just do a show CDP neighbors, and it will show us all the devices that it's connected to. Now, wow, look at that. No CDP neighbors. What's wrong with CDP? And the answer is nothing. See, switch ports by default are up, but router interfaces by default are shut down. So if we want to see CDP neighbors, we need to bring these interfaces out of shutdown. So we can do that. And because I know the physical cables are correct, I'll do a show CDP after the fact. But that's a great way to verify that a certain port, FA01, is really connected to a certain port on a switch, which happens to be part of that correct VLAN. So we'll bring the interfaces up, we'll assign the correct IP addresses with the standard command of no shutdown and IP address on the appropriate interfaces. And once these two interfaces are up and CDP messages are being sent every 60 seconds by default, we should be able, from a show CDP neighbor perspective, verify all of our connections. So now that's done, let's go over, let's also over here, let's add a routing protocol. We're going to say EIGRP is going to run, and we're going to enable it for any interfaces that begin with 10 and any interfaces that begin with 23. If network statements in EIGRP are new to you, I would recommend taking a look at my video on what the network statement really does in a routing protocol. And that will walk you through step by step exactly how that affects which interfaces are involved. So now both of these interfaces are involved in EIGRP. We're doing routing. We don't have a neighbor yet. We will once we configure our 6 over here. But let's just verify our connections. Let's do a show CDP neighbors. And this says, okay, we are connected off of our local FA00 interface, which is right here. We're connected to a switch called left switch SW2 on its F1/4 interface. Easy for me to say. So that's connecting right there. It also verifies that the other interface, FA01, on the router is connected 1/5 on the actual switch. So that's a great way of verifying that your cable plant is literally connected to the right devices. And you can verify that with a show CDP interface just to verify which interfaces are running CDP, because if CDP is disabled on an interface or not running at all, that would also prevent you from seeing who you're connected to. So the last piece of this puzzle is to configure this guy over here, which is our good friend, Mr. R6. So on R6, we'll do the same thing. We'll enable both interfaces, FA00 and FA01, and we'll also apply the correct IP addresses to them, and we'll also add a routing protocol. Why? Because R4 and R6, whether you look at them here or down here, logically, their two FA00 interfaces are going to be in the same broadcast domain, in the same VLAN. And the world, my friend, is shrinking as far as all the devices and all the logical functions that go on inside of our computer networks. So what we can also do, we can also reduce this topology and get rid of the routers. And I'll do that in another video. I won't do that in this video because it would take a little bit longer than I intended. So now we've got FA00 up, we got FA01 up. Let's go ahead and run EIGRP. And if the trunking is working correctly here, and this port are both really in VLAN 23, and these guys can see each other, they'll see each other's hellos, and they'll become EIGRP neighbors. And there's our neighborship right there. So now the last piece of this story is, can this PC ping 30.00.10? This device truly does have a correct default gateway of 30.0.0.3, and this PC does have a correct default gateway of 10.0.0.2. So let's go to the PC and we'll do a ping. So ping of 30.0.0.10, which is the IP address of this server, and we'll press enter. And we might expect to lose some because of what? Because of ARP requests being done. So where did the ARP requests have to be done? Well, this PC had to resolve the layer 2 address of R4, and R4 also had to resolve the layer 2 address of R6, and R6 had to resolve the layer 2 address of this server. So it's quite possible that one of those was already done when we had some connectivity back and forth, maybe NetBIOS or something was generating some traffic, or it needed to go out. So because of the ARP requests that were happening, we had 3. In a brand new network that's just powered on, there would be 3. Here we had 2. The next sequence of pings should have 0 misses. And we can also trace the path through the network with the trace command. Now, on a Windows box, it would be the trace RT command. On a Macintosh, it would be trace route. And on a router, it would be trace route. So we'll trace our path over to 30.0.0.10, and it will show us the full path. It says, well, the first hop was 10.0.0.2. That's this guy right here. And the next hop was 23.0.0.3. That's here. And then we finally got to the final destination, which is right here. So that's a great overview of how to configure a network with VLAN support. We have the logical topology right here, what we might see on paper, but behind the scenes, it's the physical implementation that's critical, especially if you're configuring it to make it work. Again, I would encourage you, if you want to brush up or take a look at VLANs specifically, or trunking, or anything of those natures, I've got most of those topics right here on my YouTube channel. Feel free to subscribe and take a look at it. And I wish you the best of success in all of your studies. Thanks, everybody.